Parallel lines cut by transversal. Hello friends, today we are talking about when a transversal, which is just a line that cuts other lines, decides to go through two parallel lines. They're seen right here. By parallel, I mean these two lines will never cross. This line and this line will ride next to each other forever, never touching, never getting closer to one another. Let's go to our first angle pair. Vertical angles. This is when two angles share a vertex, but they share no common sides. We have more than a couple here. We've got angle 1 and angle 4. Those would be considered vertical angles. Angle 5 and angle 8. Those would be considered vertical angles. We've also got 3 and 2. I think you get the idea. But also to be known about vertical angles is that they are always, drum roll please, congruent, meaning if angle 2 is a 60-degree angle, angle 3 would also be a 60-degree angle. Next angle. Supplementary angles. We've got two angles that add up to 180 degrees. A good example is right here with 1 and 2. You can tell it's 180 degrees because it's a straight line right here. Another example would be 7 and 8. Yet another example would be 4 and 2. As you can see, there's many supplementary angles here. Next angle. Next up, we have corresponding angles. They're going to be on the same side of the transversal, so either on this side or on this side. And what it is on the same side of the transversal, we're going to have one here will correspond with the same spot down here with this group of angles. So in this case, 1 and 5, 2 and 6. You see that they are in the same spot, just different bunches of angles. 3 and 7, and finally 4 and 8. Someone told me that a good way to think about it is that on the same side of the transversal, one of them's always outside, one's on the inside, and it's always true. And I thought it was the cleverest thing I've heard today. And, drum roll please, these guys are always congruent. Ding dong. Next angles. Next group of angles are going to bring in a new idea, the idea of alternate. Alternate meaning that one of the angles will be on one side of the transversal and the other angle will be on the other side of the transversal. It also brings in the idea of interior versus exterior. And as you see here, I've labeled between the two lines, the two parallel lines is the interior of the figure, and out here, outside the two parallel lines, is the exterior of the figure. So, what are alternate interior angles? Well, as you may have already guessed, they are two angles that are inside the interior, but on alternate sides of the transversal. So we've got 3 and 6. We also have 4 and 5. And guess what, folks? They are green congruent. How interesting! Next angles. Next up, we have alternate exterior angles, and now instead of being on the interior and here, we're going to move to the exterior out here. And so it's going to look like if I have angle 1, well, I need to be on the outside and also on the other side of the transversal, so it's going to be angle 8. As well as angle 2 would be alternate exterior angles with angle 7. And like I said last time, they are congruent. Next angle. The next up are consecutive interior angles. This means I'm going to be inside the two lines, and consecutive means one right after another. So first off, I'll go with angle 5, and I'm going to stay in the interior, and I'm going to consecutively go to angle 3. The only other option is 6 and 4. And what's strange about consecutive interior angles is that they are not congruent. Repeat, these guys, congruent? No, not congruent. But they are supplementary, meaning they add up to 180 degrees. I have beautiful handwriting. This last part, we're going to do a problem in our notebooks, and what I'm saying is that if I have two parallel lines cut by a transversal, and I know that one of the angles is 120, can I figure out all four of these angles and the other three angles? And the answer is yes. Now, using all the skills that we just learned about, I'm going to say that, well, I know that this angle down here would have to be 120. The reason why is because this angle and this angle are corresponding angles. I could then go on to say that this one has to be 120 degrees. The reason being that this angle and this angle are vertical angles, and therefore they have to be congruent. But I could also say that this angle and this angle are alternate interior angles, and therefore have to be congruent. Similar reasoning for this angle. It is a vertical angle with this one. It is an alternate exterior angle with that one. And it's also a corresponding angle with that one. Therefore, it has to be 120. Next up, I'm going to use my supplementary angles. Since I know that this one and this one have to equal 180, I can figure out that that's 60. But also this one and this one have to equal 180. So that one has to be 60 no matter what. And therefore, this one must be 60. Extremely similar reasons. These are supplementary. These are supplementary. These are, it all goes around in a circle. It's crazy. And then I can use corresponding angles and say that this one is 60 and that this one is 60. But I could also use this same logic of alternate exterior angles to say this one and this one. Or I could say alternate interior is this one and this one. Or I could even say consecutive interior and say that this one and this one are supplementary. It's all cyclic and crazy. Good job. I'm proud of you.